Hi, this is book 3 of 25070. Looking at this chart, we can work out the key of the formula. The RT is equal to the resistance at the temperature that is required, and that temperature at 0 degrees centigrade. So R0 equals resistance at 0 degrees centigrade. T equals temperature at 0 degrees centigrade. And T65 equals the temperature at 65 degrees centigrade, but it could be 35, it could be 45, it depends on the question. So T by itself is at 0 degrees centigrade, and T with a 65 or 35, whatever value is there, that is the value of the temperature in centigrade. And then alpha is the temperature coefficient of resistance at 0 degrees centigrade, and that we get from a table. So we have two temperatures other than 0 degrees or 20 degrees. Sometimes the chart that is given to us, the table, has the temperature coefficient at 0 degrees or 20 degrees, and that is Celsius. So calculate the resistance of a copper coil. Now it's copper at a temperature of 70 degrees centigrade. If the resistance of the coil at 35 degrees centigrade, if the resistance of the coil at 35 degrees centigrade is 120 ohms. Divide the question into two questions. First, find the resistance at 0 degrees. First, find the resistance at 0 degrees of the known resistance. And the known resistance in this case is 120 ohms at 35 degrees centigrade. So, the resistance at the temperature of 35 degrees centigrade equals the resistance at 0, and in brackets 1 plus the alpha at 0, or the temperature coefficient at 0, multiplied by the temperature of 35. That's what's given. So we have to transpose to find the resistance at 0. Remember, we're looking for the resistance at 0. So resistance 0 equals RT 35. Remember, RO is above the line, so it stays above the line, and the rest around it has to move. RT 35 is above the line, it's not being moved, it stays there. But the 1 plus alpha 0 and the temperature 35 degrees must move, and where does it go? It goes below. Don't forget that. So, resistance at 0 equals RT35, which is 120 ohms, and below that it's divided by 1 plus the temperature coefficient, the alpha, at 0 of a copper coil at 35 degrees. The temperature is 35 degrees. So what do we have? We have in brackets 0.14945, and it's 1 plus that. So 1 plus the 14945 gives us 1.14945. divided into 120. So the resistance at 0 is 120 divided by the 1.14945, and we have the result of 104.4 ohms. Now remember, this is at 0 degrees. That is the end of the first question. Now the second question is the resistance at 70 degrees centigrade. So at 70 degrees centigrade, we apply the formula R2 equals R at 0, and in brackets 1 plus alpha at 0 and the temperature that it's going to. In this case, it's going to be 70. So RT, the resistance at 70, is going to equal the resistance at 0 multiplied in brackets 1 plus alpha 0 and temperature 70. So R2 at 70 degrees centigrade equals 104, and remember 104.4 is the result we got for R0, and now we have 1 plus and what's in brackets. So we have 1 plus 0.2989. So the temperature, so the resistance at 70 equals 135.6 ohms. Quick review: the two temperatures other than 0 or 20 degrees centigrade. At 0 degrees of the known resistance, we found the answer there as being 104.4, and then the resistance at 70 degrees centigrade was 135.6 ohms. And there's the overall. So 35 degrees, it was my apologies. At 35 degrees, it was 120. At 0 degrees, it was 104. And then at 70 degrees, it was 135.6. So by that we can see as the temperature increases, so the resistance increases.